Hi guys, in this specific video we're going to look at the behavior of functions if we try to interchange what we call the intervals and try to see, interchanging the limits and try to see what is going to happen. So in this case we had said that we can be able to give a general representation for a definite integral over closed interval. So this is just p of x. So if an interval can be represented as fx dx over closed intervals a and b, we can be able to try and see the behavior of this specific limit. We said that this is the lower limit of integration and this is the upper limit of integration given as such. So we can be able to, of course, monitor and see what is the effect of interchanging the limits for the lower limit of integration and the upper limit of integration, and see what is the overall result for this. So suppose we have we can be able to just have a different set of intervals. Let's say this is a C and D given as such. So therefore we're going to have this one C and D as our closed intervals, so the lower limit of integration and the upper limit of integration given as such. So if we allocate numerical values for these specific limits, whereby we have C equivalent to perhaps 2 and D equivalent to 5. So let's try to see if we try to change these limits, what will be the value. So we are going to have this one given as the integral of so our D is going to represent 5, and then this is going to represent 2fx dx. So if we give an example and say that this function y is equals 3x, and of course let's just have this one as x squared, and we're going to have the integral of this one, which is the integral for this one can be given as x to the power 3 over 3 and then plus c. So in case we have a lower and the upper limits of integration, this is going to be the difference between 5 and for the value of x, the difference between 5 and 2, whereby we're going to have it represented as 5 and 2 as such. So therefore we can be able to find the value of that integral, whereby we're going to do a substitution. So this is 5 to power 3, which is 25. So this is 25 by 5. This is going to be 125. And therefore that is going to be 125 all over 3 minus, so if this one is 2, then this is going to be 8 over 2. So I hope my evaluation is correct. So this 125 minus 3, so that is going to be 117. No, so it's not going to be 100. So this is over 3. So this is going to be 117 over 3 given us value for the integral. So this is when we have the lower limit of integration as 2 and then 5. So suppose we interchange those specific limits. Let's try to see what is going to happen. So in this case, I'm going to have our value for the integral given as x cubed over 3 between 2 and 5. So I've interchanged or flipped the integrals signs for that. So this is going to give me the value of 8 over 3. So I've done a substitution for the value of x for 2. So this is going to be 8 over 3. And the value for this one is going to be 5. So it's going to be minus 125 all over 3 given as such. So this is going to give me negative 117 over 3. So if you try to look at the results for the integrals of these two specific functions, we're going to see that basically the results in terms of the magnitude is going to be the same, only that the sign is going to change for the second specific intervals for 2 for the upper limit and 5 for the lower limit. And this particular result is an opposite one for the value of 5 as an upper limit and 2 for the lower limit respectively. Therefore we can be able to have a general statement of trying to compare these particular values for the integrals if we try to flip the units, or rather the limits given as such. So in case we have that function f of x from for the over closed intervals c and d, this is going to be equivalent to the negative value over cp. So I've changed the units of the function f of x dx given as such. So this is going to apply in case we change the units. So therefore, you can be able to conclude that interchanging the limits of integration, then therefore it's going to change the sign of the integral for the positive and negative sign, depending on what the value of the initial integral was. And therefore, flipping the units will give an opposite sign for this specific value for that integral. So I hope this is going to assist us try to identify, in any case, if we find a result, or rather perhaps a value for the upper and lower limits of integration being given in this specific condition, then therefore we are going to see that the overall integral is going to assume this specific value. So catch us in our next videos. We're going to look at other various characteristics of the integrals, and these are going to assist us in evaluating some of the basic integrals that we come across. So that is it for now, guys. Bye, God bless.